previous class we talked about strings and numbers and booleans as well as fundamental types of variables in Python. So for example, we can have a variable name and it might have the type of string, and that means that we can attach a string of text, presumably containing the name, to this variable. Yeah? Or similarly, we can have a variable height, and we can have this as a numerical variable, either floating point, so we can have decimal points, or integers, so that we can have no decimal points, and then save a value to it, the height of a person, say. But there are many other types in Python that are not numbers or strings of text. Types that have more complex functionality. Types that have probably contain numbers and text, but they are more complicated structures. And one of the most fundamental ones in Python that is used throughout the programming in Python is a list. So a list is a sequence of other variables, other objects. So it can be a list of numbers, it can be a list of strings of text, and it can even be a mix of those. It can be a list of numbers and strings and other types of objects. One can even have a list of lists. So any kind of type of variable can be inside a list. And this list has a particular order. So if an item is on the 4th position in the list, that does not suddenly get moved to another position unless you as a programmer move it. So a list is a set of objects, which can be numbers, strings, or other kinds of objects in Python, that are in a rigid order. And then we can use these lists for all kinds of things. We can take one by one an item from the list and do something with it. We can append the list, or we can delete a chunk of the list. We can compare the list to a certain reference value and subset it. So we only take, say, the values that are less than or greater than a particular value. So we can do all kinds of things with lists. In our simulation, for example, you can think of political parties in the simulation and voters in the simulation. And in some of the sample code, I wrote, for example, a variable called party1 name, and then another one variable party2 name. If you have 20 parties in the system, that is going to be very cumbersome to write. You don't want to have 20 different variables, party1 name, party2 name, party3 name, etc., to name 20 parties. Much better to say, have one variable that is a list of party names, and we just have a list of 20 items long, and at each slot we put the name of that respective party. Now we have one variable containing the list of party names instead of 20 variables for each party separately. And this means that we also have a more useful name. We can just call it party names instead of party name 1, party name 2, etc. And similar for other features of the parties, right? We can have the x coordinates or the y coordinates. And since a list can contain lists, we could have one list for each party containing the name, the x coordinate and the y coordinate, and then make a list of these lists. And then every item in that list contains all this information, the name, the x, the y position, etc. So lists are very powerful to store like ranges of data. When we have many voters, many parties, many books to sell, many agents in a simulation, whatever you have, you can make a list to store the information on all of them. And this can be numerical, textual information, or more complex items. The most advanced we can do at this stage in the course is to have a list of lists, which contains already in each of those lists detailed information on each party. Later in the course we will learn about object-oriented programming, and you would probably create something like a party object and then have a list of party objects. So we create a type of variable, the party type, and then that contains all the information we need. So later in the course we will be making more advanced use of this. Now we will just focus on lists of more basic items. But you can imagine that the organization of large sets of data is much more convenient in Python when we have this list. I will show some example code of how to work with lists. So lists are a series of items, a series of values in a variable. So one variable holds a series of values, and these values can be numbers, they can be strings, or they can be other more complex objects. So for example, we might have a series of products, and we might have a variable that is contains the prices, right? So the prices might be these values. Yeah? So we have maybe 5 books, and they have 5 different prices. And they might also have 5 titles and 5 authors, etc. And we don't care about that for now. So we can then look at these prices, or we can look at what the type is of these prices, right? That follows code that we learned early in the course. Yeah, so we can see that there is a list of values, and that the type of this is the type list. So this is an example of a list of numbers. We might also have the authors. Yeah, so then we get maybe something like this. No, this is 5 books. Yeah, same number. Yeah, we can print authors, print type of authors, and we can see that we have another list. Yeah, a list with strings of text, but the overall object is a list. We can also index in this list. We can take sub-elements out of this. One thing that is very important to remember is that the first item is at position 0, the second item at position 1, the third item at position 2, etc. So in Python, we always count from 0. This is common among most programming languages, but it is different from, for example, R. So if you are familiar with R, the first item is number 1, the second is number 2. That is not common across programming languages, and it's not the case in Python. So if I want to know the price of the first book and the author of the first book, I can do something like this, right? I run that, and we get that the first book is written by Pharaoh and is 45 euros, or whatever it is. Yeah? So this way we can index the first item, or we can index the last item. Yeah? There are 5 books, so the last one is at position 4, and we get this author total. You get an error message if you try to print beyond that. So this is an error message, right? The list index is out of range. We went beyond what we can do. So this list is easy to get to get sets of information, sets of data, and we will show later how to get more complicated data there as well. Let me give you a few more examples also of this subsetting. So we can do a bit more advanced stuff. We can do the second till the 4th book. Oh, we have to remove this because it will keep running into problems. Yeah. So this is position 1, position 2, and this is not inclusive. Yeah? So you get, this means that you get the one at position 1 and the position 2, but it stays lower than 3. Yeah? So we get these 2 authors. We can also leave something out. We can do this, not give a number here at the beginning, and we get every author up till position number 3. It's position number 3. We get everybody up, but not including that number. Or we can do something like this, and we get everybody from position 2 onwards, 2 down, down. Yeah? So this is numbers 1 and 2, this is numbers 0, 1 and 2, and this is number 2, 3, 4 until the last number, which in this case is 4. So we can subset, we can take bits of the list. Now we can make more complicated values in there, but I don't want to show you that. I want to show you how we can already use the while command that we used in the previous class, and the function command, the def to create functions from the class before that. to, for example, write a function that finds the cheapest of the books, or a function that finds the most expensive of the books. Yeah. So, for example, we can do this. Define cheapest book, and it has a parameter, namely the list of prices. Now I call it prices, but it does not have to have the same name as here. In fact, maybe that is confusing to do that. I could have done anything here, right? So I can let's call it price list. And now I can use this. So my suggestion would be that we first assume that the first book is the cheapest, and then we keep checking whether something is cheaper or we have reached the end of the list. Yeah? So maybe I should have shown you first how to get the end of the list. This is done with the len command. So we can do as follows. The cheapest index is 0. We haven't found it yet. Maybe -1, so we can check. And the current cheapest price, we need to put something really high. That definitely no book is going to be lower than that. Yeah? Something very high. And then we can check while we also need to keep track where we are in the list. So we start with the first one, and then we keep checking until we reach the end. So while this is a counter variable, it just counts where we are on the list. So first we're going to look at the first case, and then we're going to look at the second, and then we're going to look at the third. But we need to keep track, because what this function needs to return is which number has the cheapest price. And to be able to return that, we need to keep track where we are. So we say I equals 0, and then while this is less than the length of the list, we can continue. And then if prices, that ith price is less than the current cheapest price, then the cheapest index is I. And then we increase I by 1. And we return the cheapest index. Let's see if this works. Cheapest book prices. Okay, that probably worked, but we need to print the result. So the fourth book is the cheapest. Sorry, did I do most expensive? I made a mistake here. So not only do we need to keep track what the cheapest index is, we also need to actually change this current cheapest. So this is going to be this. And now at position 2, there we have the cheapest book, only 12 euros. So let me talk to you about that one more time, now that we have figured out the function. So as you see, we always make mistakes and then go back and fix it, right? This is very common. So I want to find the cheapest book in the list. I need some variables to keep track of what I'm doing. I need to keep track of at which position I so far found the cheapest book. I need to keep track of what the price was of this cheapest book. And as long as I haven't found any yet, I just put a really high price, so that whatever book I find, it's going to be cheaper. And I need to keep track of where I have been checking so far. Yeah? So I need these 3 variables. And I start at the beginning of the list, and these are just these will change anyway later. They don't really matter. Then while means that as long as the condition holds. So as long as I'm not yet at the end of the list, I will keep running this block. And the moment I is not less than the length of the list, it will move to the next line. Yeah, so this means that as long as this count variable is less than the length of the list, we can keep running this loop over and over again. And note that this is less than and not less than or equal, and that has to do with this starting to count at 0. So we want to always, there are 5 items here, and we always want to be less then 5, because this is number 1, this is number 2, this is number 3, this is number 4, and this is the 5th one. So to make sure that we don't go beyond that 5th one, which is at position 4, we need to make sure that the position indicator is always less than 5, always less than the length of the list. And then we check if the price at that particular position, so this is how you get the price at one particular position, right? Or like this is at the first position. So now it's at the ith position, because we keep track of where we are in the list by looking at I. If the price at position I is less than this current cheapest price, then we need to make sure that we update which index has the cheapest book. So that has to become I, that's where we are checking. And we also need to keep track of what is currently the lowest price, because it will keep changing. So we also need to make sure that the currently lowest price is the price at that position. And then we can go to the next position and repeat the loop. If we go back again, we check the price again at that position in the list. If it's less than the currently cheapest price, then we increase the index by, we set the index for the cheapest there at I, and we set the lowest price to the price at I. And in the end, it will just return the cheapest index. Now, we could have done a few more things here. So, for one thing, I don't really like that we only get the number back. Yeah? Maybe we want to know which book it was and what price it was. So how about we also get an author list in. That means that here we also need to pass on authors. And we return not so much the index, but we return some information. We can return a list, actually. We return a list of the author list at this point and the price list at this point. So look, these are two values. This is a string of text, because we have a list of names, and we take the name at this index point of view. And this is a list of prices, and we get the price at this point of and what is returned is a list. We can run this, and now we get a list returned which has two values: the author of the cheapest book and the price of the cheapest book. So this is how you can write a function that loops over a list. Now in this class this week, in the next video, we will be talking about loops, so we will learn another way of formulating this. But while loops that we already did in the previous class can actually fully capture how to loop over a list. So this is one way. So this combination, line 24, 25 and 29 together are a way to go through a list and do something with that list. And what is done with that list is what is in this box, in this block here. And so other formulations that we will learn are just shortcuts for the same thing. But internally, what Python will do, when you type 4, which we will learn later when we talk about loops, actually internally Python is doing this. So while is a good way of looking at lists. Imagine we have these list of authors and prices. So we have authors and prices. Imagine I want to add a book to this list. So there is a command, append, where we can add at the end of the list. So prices.append, and then I can add any price that I want to add. Right? So here's a 90. So now the list is longer, it has one item more. Of course, we also need to then append authors in this case, because we need to add the author for this additional book. Yeah? I don't know. So now we've added one name. We can also insert in the middle. Maybe we want to keep it in alphabetical order, which it here isn't anyway, but maybe we wanted to. So we can do insert. Then we need to first say where we want to insert, for example at position number 3, and then add a new name. So maybe this is also written by me. I'm very prolific, of course. And then we also need to insert a price at the same spot, of course. Yeah, so now we have prices, authors. And we can still find the cheapest book by passing on the prices and the authors lists. Yeah, and we still have that Gibson is 12.50 because this new book is 99, so it's more expensive. So this is a one way of calling functions. There's basically two ways. There's functions that look like this, where what you pass on is you give the function name and then parentheses and then some parameter. But we also sometimes have functions that have an object first and then call the function on that with this dot symbol. So that's a slightly different way of calling functions, and I think we discussed that when we talked about functions. This is a standalone, this is really a function. This is what is technically called a method. A method is exactly like a function, but it is a function for a specific type of object. So list objects have this append function. In fact, we can see what functions are there with the dir command. So if I do dir prices, we get all the functions that we could have called like that. We see insert here, we see append, but we can also copy, we can sort it, we can count it. We can, for example, try prices.sort. And now if you look at prices, it has been sorted from low to high. It's a big problem because now we don't know anymore which author belongs to which book. So this was probably quite damaging. You don't want to do this in a program. But it's just to show how you can find these functions and call them. Or we can reverse. And then when we look at it, it's now in the reverse order. Yeah? So these are functions here in this case that actually affect the list directly. They change the list and they change the content. Since inside lists we can have different types of objects, including lists themselves, we can make quite complicated lists. So let us think first a little bit about the books and the prices that we had. So we had a list that looks something like this, that has different prices. And then we have maybe an authors list. Yeah. So these are just the names of authors and the prices of their associated books. And there's titles of course as well, but I don't want. I'm too lazy to type those. Now one thing that we saw, for example, when we sorted this list or when we inserted a new book, is that we now have to really keep track of the fact that these prices belong, that there's a mapping, that the first price goes with the first book author, the second price goes with the second author, and so forth. That, of course, is just bound to lead to bugs. It's so easy to make a mistake somewhere in the code that maybe removes an author but forgets to remove the associated price, or that removes an author but then accidentally removes the wrong price, and so forth. So this is a very risky way of programming. So how can we think about this otherwise, still using just lists? So one thing we can do is to make a list of lists. It's a bit confusing to get your head around, but it can be useful. So maybe instead of prices and authors, we can think of books. Yeah? So book 1 is maybe written by Brown, and it has a price of 32 euros. And book 2 is written by Gray and has a price of 12.50. And then we can maybe make a list of books and just do this in one go. So the first item is by Brown with a price of 32.43, and the second item is by Gray with a price of 12.23, and so forth. There's a typo here, I see. And let's see if this works. So I'm not sure whether Python is happy with this blank line there. No, that does not seem to have worked. Yeah, that worked. Okay. So this formulation works. So we have a list with these square brackets, makes it a list. And then within each list as items, we have also each time a list. These are also lists. So to find the first book, we can do this. And to find the author of the first book, we can go to the first item of the first item of this list. Yeah, so we find that the first book is by Brown and it's 32 valuable, and then the name of the author is Brown. Yeah? And the price would be something like this. Yeah? So we can now optimize our cheapest book function by immediately returning this item and looking at it more closely. No, I'm not going to do that now, but this is a list of lists. So imagine a similar thing with where the first item on the list would be the name of a party, the second item would be the x coordinate, the third item would be the y coordinate, and then we could make a list of lists that contains all the parties and their associated positions. One thing to be a little bit careful with lists is when you try to copy them. We probably don't encounter that too much into our programming, but it's just something to be aware of. Imagine I have two lists, a list A, or list authors. Yeah? And this list consists of these names. Yeah, so I can print these authors, and there's my names. Now I might have a new variable. For example, what can I say? Maybe names, and I make it similar to the list of authors. So if I print names, I have the same list. The thing to be really careful with is that you might have thought here that you made a copy, that now you copied authors into names. But actually you did not make a copy, you just refer to the same underlying list. If I change the second item, or the third item here with the new name, and I look at names, so I have replaced this name Dessa with the name De Boer, then what is probably going to be surprising is if I look at authors, I have also changed it. So this does not make a copy. It just means that these are now two names that refer to the same list, and if I make changes to the list, I will have changed both. So that's quite important to keep in mind. What I probably meant to code is something like this. Because now names and authors are the same, but if I change an item in names, then names has changed, but authors has not. So for lists, if you think that this copies it, it doesn't actually. It only copies the reference to the list. This is the command to actually copy the list. So we probably won't encounter that anytime soon. It's not so important. It's just helpful to be aware of this. So in this video we have looked at lists. Lists are so important for programming that some programming languages have been designed entirely around lists. For example, there's the Lisp programming language, which is designed around the use of Lisp. Python is not. Python is designed primarily around object-oriented programming, and this is the main sort of design philosophy. But lists are really quite important, and Python has learned a lot from these older languages that were designed around lists, around the manipulation of lists per se. So Python does have fairly advanced features such as mapping, which means applying a function automatically to each element of a list separately, or filtering, which means selecting items from a list, selecting a subset based on some criterion. And the most powerful tool in this regard is what is called list comprehensions. In list comprehensions, you create a new list based on some manipulation of an existing list, and this can be formulated with very little code. So in a very sort of tight form of commands in Python, you can formulate a list comprehension, which means generating a list out of an existing list through some manipulation, maybe through selection or through applying some functions. So in other words, a list comprehension is a sort of condensed form to do either mapping or filtering. Now, using list comprehensions is certainly beyond this course, and you should not worry about it now. You should worry about understanding how data can be stored in lists and how you can loop over a list to do anything, either with a for loop over the list or with a while loop where you keep track of how far you are in the list. But you will, when you look at existing Python code, you will see these other functions around. And so when you get a bit more advanced in Python, I would strongly recommend that you certainly learn how to work with list comprehensions, and also learn a little bit about these other tools such as mapping and filtering that originally come from functional programming languages. So I have not discussed this much yet, and I might get back to you about it when we talk about object-oriented programming. But generally speaking, most programming languages fall either in the more functional programming or the more object-oriented programming category. Python is very much an object-oriented programming language, but they have learned from functional languages and applied some of these features that are typical there. So that's a bit of an extra, not core to understanding the concepts, but just to give you a bit of context.